Welcome in .Cool. Asteroid 2024 YR4 won't hit Earth, but it does carry a 4% chance of striking the Moon in 2032. An impact that could carve out a crater, scatter debris into Earth's orbit, and test whether humanity is ready to face a cosmic threat. In this video, we'll explore how it was discovered, what a potential lunar impact would mean, and how scientists are preparing to respond. From discovery to present risk, when 2024 YR4 was discovered, astronomers tracked its orbit with limited data. Early models put its chance of hitting Earth at around 3%, which is unusually high in planetary defense terms. That estimate didn't last long. With more observations, the orbit became clearer. Earth was never in real danger. The focus shifted to the Moon. Current models place the probability of a lunar strike at just over 4%. That may sound small, but in space impact monitoring, it's enough to trigger serious consideration. So, what would happen if it hit? Its diameter is estimated at 53 to 67 meters, similar to the object believed to have caused the 1908 Tunguska explosion in Siberia, which flattened thousands of square kilometer forest. On the Moon, such an impact would excavate a crater about a kilometer wide, releasing energy equal to multiple megatons of TNT. But the direct damage to the Moon isn't the concern. Instead, scientists worry about ejecta, debris blasted off the lunar surface. Some of it could escape the Moon's gravity entirely and spread through CIS lunar space, the region between Earth and its satellite. If that happens, Earth could experience a short but intense increase in micrometeoroids. For ordinary people, this might translate to a spectacular meteor display. For satellites, space stations, and crewed missions, it could mean sudden and serious risk. Tiny, fast-moving fragments can punch holes in spacecraft walls or disable electronics. This is why a 4% chance matters. Even if the most likely outcome is a miss, the potential consequences justify careful preparation, and there's still uncertainty. Observations in 2028 will give astronomers a sharper view of its orbit and could either rule out a lunar impact or raise the alarm further. Options for action: if observations confirm that Y4 is on a collision course with the Moon, humanity has two main strategies: deflection or disruption. Deflection is a preferred option. The idea is simple: alter the asteroid's path just enough to miss. The earlier this is attempted, the smaller the adjustment required. A spacecraft could deliver this nudge through a high-speed impact or by acting as a gravity tractor, slowly tugging the asteroid over time. The challenge is that we don't know Y4's mass. While size estimates are reliable, density is uncertain. Depending on composition, it could weigh anywhere between tens of millions and hundreds of millions of kilograms. A mission plan with the wrong assumptions could fail or worse, alter the orbit unpredictably. That's why many scientists argue for a reconnaissance mission. By flying close to YR4, a spacecraft could measure its mass and structure directly. The issue is timing. The ideal window for such a mission is around 2028. That leaves only 4 years before the potential impact date. Tight, but possible if treated as a priority. If deflection proves impractical, the alternative is disruption. Here the goal is to break it into smaller fragments. Two approaches are under discussion. Kinetic disruption, using a heavy impactor to shatter it. This builds on lessons from NASA's DART mission in 2022, which successfully altered the orbit of Dimorphos. But in this case, the strike would need to fragment it, not just move it. Nuclear disruption, the most controversial option. By detonating a 1 megaton device a short distance from the asteroid surface, a standoff burst. Calculations suggest it could be completely disrupted regardless of its mass. Treaties limit nukes in space, but they may be the sheerest way to disrupt it. With 2030 to 2032 launch windows leaving little margin for delay, why it matters, some might ask why this matters at all. The Moon has survived countless impacts, and even if YR4 struck, Earth itself would remain unharmed. But the consequences ripple outward in ways that touch modern life and future exploration. The most immediate concern is satellite safety. A sudden increase in micrometeoroids could threaten navigation, communications, weather forecasting, and defense satellites. Even a short-lived storm could cause billions in losses and disrupt vital services on Earth. There's also the issue of astronaut safety. By the 2030s, NASA, ESA, China, and private companies plan to have astronauts near or on the Moon. An impact event in that time frame could place missions at risk, either directly or through the hazards created in orbit. Beyond risk, there is scientific opportunity. A modern lunar impact of this scale will be the largest ever observed directly. Astronomers could watch the formation of a major crater in real time, track how ejecta disperses, and refine models of impact physics. This knowledge feeds back into planetary defense by improving predictions for larger, more dangerous objects. And then there's the bigger picture. 2024 Y4 is not unique. Thousands of near-Earth objects cross our orbit, some far larger. The process is being debated now. How to track, how to decide, how to act will be the same ones applied when a truly dangerous asteroid appears. In that sense, it is a rehearsal for challenges humanity will inevitably face. So, while Earth isn't in danger this time, the situation highlights our responsibility as a space-faring civilization. We're no longer passive observers of the sky. For the first time in history, we have the technology to alter cosmic events. Whether we use it and how is both a scientific and political question. Outro asteroid 2024 YR4 isn't a threat to Earth, but its 2032 moon strike chance reminds us to stay prepared. By 2028, we'll know if action is needed. So follow along as humanity learns to defend its place in space. Thanks for watching Dark Core.